Alright kids, welcome to day 2. We are going to look at rates of solution and molarity today. And molarity is a measure of concentration using our all-time favorite, moles. Alright, so start here with the catalyst, pause the video here, and take a moment to complete the catalyst. Okay guys, let's get started. So let's first ask the age-old question, how do I get sugar to dissolve in my iced tea a little bit faster? So there are 3 ways that you can do this to increase the rate that sugar dissolves in your tea. First, you can stir, and then stir some more. Second, you can add sugar to your warm tea and then add ice. Or third, you can grind the sugar to a powder and then add the sugar to your tea. So let's talk about these for a second. When you're stirring, you get that fresh contact between solute and solvent. That's what allows it to dissolve a little bit faster and allows it to be homogeneous throughout. If you add sugar to warm tea and allow it to dissolve, you have a faster rate of dissolution. You can dissolve a little bit more quicker at your higher temperature. Or you can grind the sugar to a powder so that you have a greater surface area, which allows it to dissolve a little faster. The question here is, which dissolves faster, a sugar cube or a sugar packet? And it's always the sugar packet because you have more surface area. So let's talk about molarity. It's not difficult by any stretch of the imagination, but there are some things that you need to pay attention to. So the behavior of the solution depends on the identity of the solution, or the solute, as always, but also the concentration of the solution. 2 solutions can contain the same solute, but behave very differently because of the concentration of those compounds. A solute, or our concentration is always how much solute do you have in a solvent. The more solute you have, the more concentrated it is. The opposite of concentration is a dilution. If you think about like just orange juice versus orange juice concentrate, right? When you take a concentrated can and you add water to it, you're creating a dilution. This is how they make soda at all the soda fountains. You take concentrated soda syrup and then you dilute that soda syrup with carbonated water. There are several concentration units, percent by mass. If you look at your hydrogen peroxide bottles, it will say 3% by mass. You can do percent by volume, parts per million, parts per billion. We look at this mainly when we're looking at the concentrations of chemicals in air. And then molarity. And molarity is what we're going to use in chemistry class. You will see these other concentrations. You need to know that those are units of concentration, but you need to be able to calculate molarity. Molarity is just one of the ways to calculate it. It is very simple. It's moles divided by liters, or N for number of moles divided by V for volume. Molarity is always a big M, so when you report your units for molarity, it is moles divided by liters, but you just shorten moles divided by liters to M. If you have questions about that, feel free to ask me about that when we get back. So a 1 molar solution contains 1 mole of solute per liter. So 1 mole per liter, or 1 molar with a big M. You may have seen this before in physical science as the density triangle. We can also look at it as a molarity triangle. So if this is molar, right, my concentration molar, this is number of moles, N, and this is volume in liters. We can cover up one of these 3 in order to get us the equation that we need for molarity. So if I'm looking for If I'm looking for molar, I cover up molar, and I see that it's N divided by B, or moles divided by liters. If I'm looking for moles, I can cover up N, number of moles here, and see that my equation is molarity times volume. And if I'm looking for volume, I can cover up volume and see that my equation is number of moles divided by concentration molar. Note that the equations are also located here. So if you just want to memorize the equations instead of our molarity triangle, that works as well. Okay, if I wanted to prepare a 1 molar solution, there are a couple things that I need to know. Let's say, for instance, I'm preparing a 1 liter of a 1 molar sodium chloride solution. So I need to figure out how many moles I need per liter, right? And in this case, I'm just doing per 1 liter, so that's kind of nice. So I'll need 1 mole of sodium chloride for my 1 molar solution. So I weigh out 58.5 grams of sodium chloride. I got that number from finding the molar mass. At this point, you need to be able to find the molar mass and convert between moles and grams of any substance. So I do that. I find my 58.5 grams of sodium chloride, and then I add enough water to make 1 liter of solution. So here we go. I would add my 58.5 grams, and then I would fill it up to the 1 liter mark, and then I would mix it. Okay? Alright, so let's talk about some equations, and let's talk about our tips for success here. If you see milliliters, 1,000 milliliters equals 1 liter. So if given your milliliters, divide by 1,000, and that will get you to liters. If it gives you grams of solute, or it asks for grams of solute, you need to use molar mass to get to moles. You can use mole mountain. If you're given grams, then you can just divide by molar mass. But you need to be able to interconvert between grams and moles at this point. Let's look at a molarity practice problem. What's the molar NaCl concentration if you have 0.5 moles of NaCl in 1 liter of solution? So remember, our molarity equation is moles divided by liters. So I would take, and it's very simple, I take 0.5 moles divided by 1 liter, which will give me 0.5 moles per liter as a unit, which I would then change to big M for molar, right? These two units right here are interchangeable. Let's look at the next one. What is the molar concentration of NaCl if you have 0.5 moles of NaCl in 0.5 liters of NaCl? Super simple again. Take moles, divide by liters. Right? Our concentration is moles divided by liters, moles divided by liters, moles divided by liters. So I have here, I have moles, then I divide it by liters. That gives me 0.5 divided by 0.5, or 1 mole per liter, equals 1 molar. Super simple. Here, if I wanted to know the molarity of a solution by dissolving 10 grams of NaCl in 1 liter of solution, I need to convert 10 grams to moles. If you're looking at molarity, again, you need to be able to interconvert between grams and moles. So we're given grams, not moles. There's no answer for this problem. You can figure it out. All right, here's some practice for you. How many moles of hydrochloric acid, HCl, are present in 2.5 liters of 0.10 molar hydrochloric acid? Pause the video, try and figure it out. Okay, here's your given 2.5 liters of solution, right, and 0.1 molar hydrochloric acid. Right, so I'm given the volume and I'm given the concentration. If I go back to my molarity triangle and I cover up moles, that's what I'm trying to find, I should see an equation that looks like this. Moles equals molarity times volume. right? So in this case, 2.5 times 0.1. Next question. All right, here we go. What volume of 0.10 molar NaOH solution is needed to provide 0.5 moles of NaOH? Right, so I'm given a molarity. I'm given moles. If I go to my molarity triangle, given moles, given molarity. If I go to my molarity triangle, I use the equation volume equals number of moles divided by molarity, right? So number of moles divided by molarity, volume equals, there we go, number of moles divided by molarity. All right, then I would get 0.5 divided by 0.1 equals 5 liters, right? So I just take my number of moles, 0.5, divided by molarity, 0.1. Now there are a couple things I want you to see here. Molarity is moles per liter. So if we're looking at our units, and this is how you find liters in your units. I have moles here. I'm going to change molarity or molar to moles divided by liters. And if this is on the bottom of a fraction, then you can switch it and make it up top. That's where this 1 liter came from, because I took this 1 liter down here and I moved it up top. And that just helps you to cancel out your units. So my moles would cancel, right, and I'd be left with 5 liters. Okay, here's more practice. How many grams of CuSO4 are needed to prepare a 250 milliliter solution of 1 molar CuSO4? Notice this is asking for grams. I have to find moles first. And also notice that this is in milliliters. Take a second, try it out. Good, okay, so you're given 250 milliliters of solution, and you're given 1 molar copper sulfate as your solution. You're trying to find grams. So if I go to my equation, I have to cover up moles, because I have to get moles before I can get grams. Right, and I'm going to use moles, N equals molar times the volume. Right, and so, again, change this volume to 0.250 liters. Right, and then you can just do 1 times 0.250. And that should give you your number of moles, right? And then from there, you'll have to convert to grams. Okay, I know it's a little bit of a mess, but that should help you get started. Have a good day.